Subject Physics 1. I. Define an equipotential surface. Answer. Equipotential surface, a surface drawn in an electric field at which every point has the same potential, is known as equipotential surface. 2. Write any two properties of an equipotential surface. Answer. Properties. A. No work is done in moving a test charge from one point to another over an equipotential surface. B. Electric field is always normal to the equipotential surface at every point. 2. State the conditions for the phenomenon of total internal reflection to occur. Answer. I. Light ray must travel from a denser to a rarer medium. 2. Angle of incidence must be greater than the critical angle. 3. Why do the electric field lines never cross each other? Answer. Because, if they do so, at the point of intersection two tangents can be drawn, which would represent two directions of electric field at that point, which is not possible. 4. Why are the electrostatic field lines always normal to the surface of a conductor? Answer. If the electrostatic field lines are not normal, then electric field would have a tangential component which will make electrons move along the surface, creating surface currents, and the conductor will not be in equilibrium. 5. Give two uses of eddy currents. Answer. Magnetic braking in electric trains. To produce heat in induction furnaces. 6. What is meant by mutual induction? Answer. When a changing current is passed through a coil, an EMF is induced in the neighboring coil due to change in magnetic flux passing through it. This phenomenon is called mutual induction. 7. Define the term wattless current. Answer. The current which flows in a circuit without consuming any electrical power is called wattless current. 8. Can the voltage drop across the inductor or the capacitor in series LCR circuit be greater than the applied voltage of the AC source? Answer. Yes, because in series LCR circuit or are not in same phase, hence cannot be added like ordinary numbers. 9. Describe briefly any two energy losses, giving the reason of their occurrence in actual transformer. How are these reduced? Answer. A. Copper loss, energy loss due to resistance of primary coil and secondary coil is called copper loss and can be minimized by using thin copper wires. B. Iron loss, energy loss as heat due to eddy current in the iron core is called iron loss and can be reduced by using a laminated iron core. C. Hysteresis loss, magnetization of iron core is repeatedly reversed by the alternating magnetic field and energy is lost in the form of heat in the core. This is called hysteresis loss and can be minimized by using a core of a material having low hysteresis loop. D. Flux leakage. There is always some flux leakage, that is, all of the flux due to primary does not pass through the secondary. It can be minimized by winding primary and secondary coils one over the other. 10. How is the transformer used in large-scale transmission and distribution of electrical energy over long distances? Answer. A. Output voltage of power generator is stepped up so that current is reduced and as a result line loss too is also reduced. B. It is then transmitted over long distances to an area substation where voltage is stepped down. C. It is further stepped down at local substations and poles before a power supply of 220 V reaches our homes. 11. What are electromagnetic waves? Are these waves transverse or longitudinal? Answer. The waves produced by accelerated charged particles, in which there are sinusoidal variations of electric and magnetic field vectors at right angles to the direction of propagation of wave, are called electromagnetic waves. Electromagnetic waves are transverse in nature. 12i. How are electromagnetic waves produced? Explain. 2. What is the source of energy of these waves? Answer. I. Electromagnetic waves are produced by accelerated oscillating charges. A charge oscillating with some frequency produces an oscillating electric field in space, which produces an oscillating magnetic field perpendicular to the electric field, which in turn is a source of electric field. This process goes on repeating, producing EM waves in space perpendicular to both fields. 2. Source of energy of electromagnetic waves is the energy of accelerated oscillating charge. 13. When can a charge act as a source of EM wave? Answer. When the charge is either oscillating or accelerated. 14. What is meant by the transverse nature of electromagnetic waves? Answer. And are perpendicular to each as well as perpendicular to the direction of propagation of the wave. 15. How are the directions of the electric and magnetic field vectors in an EM wave are related to each other and to the direction of propagation of the EM waves? Answer. And are perpendicular to each as well as perpendicular to the direction of propagation of the wave. 16. What is the frequency of electromagnetic waves produced by oscillating charge of frequency? Answer. Frequency of electromagnetic wave is equal to frequency of oscillating charge. 17. When monochromatic light is incident on a surface separating two media, the reflected and refracted light both have the same frequency as the incident frequency. Why? Answer. Reflection and refraction arise through interaction of incident light with atomic constituents of matter which vibrate with the same frequency as that of incident light. Hence, frequency remains unchanged. 18. Define refractive index of a transparent medium. What is minimum and maximum value of refractive index? Answer. Refractive index of a medium is defined as the ratio of velocity of light in vacuum to the velocity of light in that medium. Minimum value of refractive index is 1 for air and maximum is 2.42 for diamond. 19. A comb run through one's dry hair attracts small bits of paper. Why? What happens if the hair is wet or if it is a rainy day? Answer. When a comb is run through dry hair, it gets charged due to friction. Molecules in the paper gets polarized by the charged comb resulting in a net force of attraction. If the hair is wet or it is a rainy day, friction reduces, comb does not get charged and thus it will not attract small bits of paper. 20. Define electric line of force electric field line. Answer. An electric field line may be defined as the imaginary straight or curved path, along which a unit positive, isolated charge would tend to move if free to do so. 21. Define current density. Write its SI unit. Is it a scalar or vector quantity? Answer. Current density, electric current flowing normally per unit area of cross-section is called current density. It is a vector quantity. Its SI unit is A. 22a. Define resistance of a conductor. Write its SI unit. B. What are the factors on which the resistance of a conductor depends? Answer. A. Resistance. It is the ratio of potential difference applied across the ends of a conductor to the current flowing through it. Its SI unit is ohm. B. Factors I. Length of the conductor. 2. Area of cross-section of the conductor. 3. Nature of material and temperature. 23A. Define resistivity of a conductor. Write its SI unit. Answer. A. Resistivity. Resistivity of the material of a conductor is defined as the resistance of conductor of that material of unit length and unit area of cross-section. Its SI unit is ohm meter. 24. Nichrome and copper wires of same length and same radius are connected in series. Current I is passed through them. Which wire gets heated up more? Justify your answer. Answer. Nichrome. Reason. Resistivity of Ni. Resistivity of Cu. 25. Define the term conductivity of a conductor. On what factors does it depend? Answer. Conductivity. It is defined as the current flowing per unit area per unit electric field. It is also defined as the reciprocal of resistivity. Factors I. Nature of material and 2. Temperature. Relaxation time. 26. Resistance of a conductor increases with the rise in temperature. Why? Answer. Due to increase in frequency of collision of electrons with ions atoms in the conductor. 27. If a wire is stretched to double its original length without loss of mass, what will be its new A. Resistivity, B. Resistance? Answer. A. Resistivity will remain same. B. Resistance will be 4 times the original resistance. 28. Explain why alloys like constantan and manganese are used for making standard resistors? Answer. Resistors. Answer. Because they have 1. High resistivity, 2. Very small temperature coefficient of resistivity, 29. Define internal resistance of a cell. Write any 2 factors on which it depends. Answer. Internal resistance. It is the resistance offered by the electrolyte of a cell to the flow of current between its electrodes. Factors I. Nature of electrolyte. 2. Concentration of electrolyte. 30. The EMF of a cell is always greater than its terminal voltage. Give reason. Answer. Because there is a potential drop across the internal resistance of the cell when cell is in a closed circuit. 31. Can the value of terminal potential difference be greater than the EMF of a cell? Answer. Yes, during the charging of the cell. 3.2. Graph showing the variation of current versus voltage for a material GAS as shown in figure. Identify the region of. Identify the region of. I. Negative resistance. 2. Where Ohm's law is obeyed. Answer. I. Region DE because current decreases on increasing voltage. Region AB because current increases linearly on increasing voltage. 33. Define the term drift velocity of charge carriers in a conductor and write its relation with the current flowing through it. Answer. Drift velocity, the average velocity acquired by free electrons of a conductor in a direction opposite to the applied electric field, is called drift velocity. 34. How does the random motion of free electrons in a conductor gets affected when a potential difference is applied across its end? Answer. Random motion is partially directed towards positive end of conductor. 35. When electrons drift in a metal from lower to higher potential, does it mean that all the free electrons of the metal are moving in the same direction? Answer: no. The drift velocity is superposed over the large random velocities of electrons. 36. The electron drift speed is estimated to be only a few for currents in the range of a few amperes. How then is current established almost the instant a circuit is closed? Answer: when the circuit is closed, electric field is set up in the entire circuit instantly with the speed of EM waves, which causes electron drift at every portion of the circuit. A current starts flowing in the circuit almost instantly. 37. If the electron drift speed is so small, and the electron's charge is small, how can we still obtain large amounts of current in a conductor? Answer: because the electron number density is very large. 38. The electron drift arises due to the force experienced by electrons in the electric field inside the conductor. But force should cause acceleration. Why then do the electrons acquire a steady average drift speed? Answer: each free electron does accelerate, but due to frequent collisions with ions they acquire only an average speed known as drift speed. 39. What happens if the galvanometer and cell are interchanged at the balanced point of the Wheatstone bridge? Would the galvanometer show any current? Answer: balanced condition still remains satisfied, hence galvanometer does not show any current. 40. Explain, giving reasons, how the internal resistance of a cell changes in the following cases. I. When concentration of the electrolyte is increased. 2. When area of the anode is decreased. 3. When temperature of the electrolyte is increased. Answer: I. Internal resistance increases. Reason: inter-ionic attractions increase and the movement of the ions become difficult. 2. Internal resistance increases. Reason: lesser area of the anode decreases its tendency to attract its oppositely charged ions. 3. Internal resistance decreases. Reason: both inter-ionic attractions and viscous forces decrease at higher temperature. 41. A potential difference is applied across a conductor of length and diameter. How is the drift velocity of charge carriers in the conductor is affected when I is halved, 2 is doubled and 3 is halved? Justify your answer in each case. Answer: I will become half as. 2 will become half as. 3 will remain same as it does not depend on diameter. 42. State Biot-Savart law. Answer: Biot-Savart's law, it states that magnetic field due to a current element at a point having a position vector relative to the current element is found to depend I. directly on the length of current element, 2. inversely on the square of the distance, 3. directly on the sign of angle between the current element and the position vector, 4. directly proportional to the current. 43. What is the source of magnetic field or magnetism? Answer: the electrons revolving in atoms behave as current loops. These current loops give rise to magnetism. 44. Does a magnetic monopole exists? Justify your answer. Answer: no, a magnetic monopole does not exist. The reason is that magnetic field is produced by a current loop and not by monopole of a magnet. 45. Draw the magnetic field lines due to a circular wire carrying current. Answer: 46. How are the magnetic field lines different from the electrostatic field lines? Answer: The magnetic field lines form closed loops while the electrostatic field lines originate from positive charges and end at negative charges. 47. Why do magnetic field lines for continuous closed loops? Answer. Because a magnet is always a dipole and as a result, net magnetic flux is always 0. 48. Can two magnetic lines of force intersect each other? Justify your answer. Answer. No, because if they do so then at the point of intersection two tangents can be drawn which would represent two directions of magnetic field, which is not possible. 49. Magnetic field lines can be entirely confined within the core of a toroid, but not within a straight solenoid. Why? Answer. Magnetic field lines can be entirely confined within the core of a toroid because toroid has no ends. But a straight solenoid has two ends. If the entire magnetic flux were confined between these ends, the magnetic field lines will no longer be continuous. 50. Depict magnetic field lines due to two straight, long, parallel conductors carrying steady currents and in the same direction, to opposite direction. Answer. 2.